Okay, example 4.3 is a really good example of how we can use the properties of exponents to simplify an expression, which will make the problem of filling out this table and plotting the graph much easier. So if we have y equals 1/3 raised to the x raised to the negative 1, that's the same as 1/3 raised to the negative 1 times x, which is the same thing as 1/3 raised to the negative 1 raised to the x. And now, if you have something raised to the negative power, that's the same as flipping it. So I could write this as 1/3 to the negative 1, because 1 to the negative 1 power is still 1. And then I could raise that all to the x. Well, if you have 1/3 to the negative 1, that's the same as just 3. Okay, so the point here is that if you know your properties of exponents, you can simplify this expression to be y equals 3 to the x, which makes filling this table out much easier. And okay, so we know that if you plug in 0 in for x, you're going to get 1 in for y. If you plug in 1 in for x, you get 3 for y. So 1 comma 3 is a point on this graph. If you plug in negative 1, you get negative 1 comma 1/3. Negative 1, 1/3. If I plug in 2, I get 3 squared, which is 9, so that's 2 comma 9. So already the points are off the graph here. If I plug in negative 2, I get negative 1/9. So it's negative 2, 1/9, which is really close to 0 already. And then if I plug in 3, I'm going to get 3 to the 3rd, or 27. I won't plot that. If I plug in 3 to the negative 3rd, that's the same as negative 3 comma 1/27, which is really, really close to 0. So the graph looks something like this. It's really, really small, just barely greater than 0. It goes through 0, 1, it goes through 1, 3, it goes through 2, 9, 3, 27, and it grows really, really fast. It almost becomes a vertical line really quickly.